Hi, my name is Ian Johnson. I'll be presenting a talk on using IoT in the Wolfram language in Mathematica 11. I work for Wolfram developing communication protocols and working with devices like Arduinos and Raspberry Pis. This talk is about using the built-in channel framework in Mathematica and some new features that we're going to be adding to the channel framework and how you can use it for specifically Internet of Things applications. So let me start the slideshow. Okay, so just an overview of things I'm going to talk about. A little bit on just what the channel framework is, what you can use it for, and then on specifically Internet of Things, and then talking about the MQTT protocol, which is going to be a big thing of Internet of Things, and then the specific devices that are all sitting in front of you. And feel free to ask any questions if you have stuff like that. This is kind of meant to be more of a workshop kind of talk, so interactive. You can play with devices, ask me questions about stuff. So yeah. Okay, so let me make this a little bit bigger. Is that big enough? Okay. All right, so the channel framework is new in Mathematica 11. Igor gave a talk on it the other day. It allows communications between Mathematica and other systems. That might be another Mathematica kernel. That might be a device like what's sitting in front of you. It could be a server like an Amazon Lambda or EC2 instance or whatever. There are lots of different places that you can have systems talk to the channel framework. It's what's called a pub/sub mechanism, and that's kind of what that stands for is publish subscribe, and it allows it's a particular model of communication where you have clients that all connect to one centralized server or one centralized thing. It might not necessarily be one server. You could have it like load balanced or something. But and then those clients subscribe on particular topics or channels, and then other clients can send on those channels, and they'll receive the clients that are subscribed on those channels will receive any messages that are published on those. And so it allows for one-to-many. So one publisher sends out something on a channel, and a bunch of subscribers get it, or one-to-one. One subscriber gets something, many-to-one. It allows for lots of different communications patterns. And currently, the implementation in 11.0 uses the HTTP protocol, which is works well for allowing lots of different variety of systems to connect to it, including devices and other programming languages like JavaScript, etc. Yeah, so that's just kind of overview of that. Yeah, so I'm going to explain a little bit how the HTTP interface works so that I can contrast that with the proposed MQTT one. So let me just make sure that demo channel is going. Okay, so I'm going to create this this demo channel and make it public, so you can go to that link if I make that into a URL and open that in the browser. So this is just the web page for that, and using the REST API for the channel framework, you can send stuff through the web browser. So I don't know if y'all can see this. You'll see the typing at the top? I guess so. No, oh, whoops, sorry. Forgetting how that REST API works. And so using the REST API, you can send data by using the send operation, and then, I don't know, just say param1 equals, I don't know, some number, etc. So that gets sent through the REST API, and that's how you can send data through the REST API. And then, actually, I wasn't listening. Let me listen on the channel. So there's now an active channel listener. So I send it, and now it shows up here, and I got the message. So that's how the clients can send data to the channel framework. Super easy, just a simple REST call. Now, receiving data for clients is where it gets a little bit more complicated, and that's where we use what's called HTTP long polling. And so I'll show you what that looks like, and how does it have to be mode. Okay, there we go. Okay, sorry. So you'll notice it's a little hard to see because I don't know how to zoom in on the browser, but the page is just loading and loading. It's waiting for a message to be received. And so how HTTP long polling is the client makes the connection, and then the server just leaves that connection open until a message arrives, and then it sends it. And so this page will just continue to load indefinitely until we send a message. So I'm just going to send that message. And so now you see here the message has been delivered by the server. So the kind of a disadvantage of using long polling like this is it means that as soon as you get a message, then you have to reopen a connection, and it gets kind of complicated managing those connections and handling that asynchronous task like that. And so that's one of the reasons why we're going to implement a MQTT method that I'll talk about in just a second. But why is the channel framework very useful for Internet of Things applications? Well, with Internet of Things, you're going to have a lot of heterogeneous systems, such as maybe you have an Arduino or a Raspberry Pi or the devices in front of you. You have lots of different systems that are publishing or like creating data, or maybe they're analyzing it and working on that. And you want so you have lots of different systems that operate very differently, but you want a unified way to interact with the data and to control all of these devices, hence using a framework for that. And I think a lot of solutions to IoT currently really kind of fail at having a consistent way to control all of that. And so, yeah, so Internet of Things, it's important to have remote control of the devices, right? You might have 100,000 sensors out in the field that you never see and are miles away from any actual person to work on. So, remote evaluation and remote control is really important for these kind of devices. So this is where the MQTT protocol comes in. MQTT was designed specifically for devices. It was designed for really lightweight communication protocol, or it was designed as a lightweight communication protocol. I think some messages that are sent over MQTT can be like 2 bytes, whereas with HTTP, you have lots of overhead, and it could be, I don't know, hundreds of bytes just to send a simple hello world message. Whereas with MQTT, that's like very, very minimal. There's very little overhead. And so it makes it very efficient for moving lots of data, and it's also very easy for clients to implement, it's very easy for clients to interact with it, because the MQTT protocol was designed such that a majority of the load processing is put on the server side rather than the client side. So that's why you can have simple little clients like the one sitting in front of you, or even simpler, smaller ones, interact with MQTT systems because they're so, because it's such a lightweight protocol. Again, MQTT is pub/sub, and in future versions of Mathematica, you'll be able to interface with MQTT networks using the channel framework. And so the same functions that channel send, channel listen, those will all have analogous effects on interfacing with MQTT networks. And yeah, like I said, it's a very popular protocol, and there are lots of client and server software available for it. Mosquito is one of those that's written in C. There's VernMQ, there's RabbitMQ, there's all sorts of server and client software for this. Okay, so now what's sitting in front of you? So I'm going to exit full screen for a second. So what's sitting in front of you, I also have one up here. There's a few different parts to this. The first thing, the main thing, is this chip here, which is called the ESP8266. It's a simple little chip that connects over Wi-Fi and has digital pins. It can do SPI interface. It can do I2C, and so it can communicate with other sensors that you might have that you need to interface with. And then I have this little chip right here is an analog to digital converter, because the ESP only has one analog channel. But on the joystick over here, I have the 2 analog channels, one for X and Y. So in just a second, when I start having you all play with the devices and move the thing around, you'll notice that the joystick is a little wobbly, so be careful with it, I guess. And if the red light ever goes off, that means it disconnected from the network, so just try unplugging it and plugging it back in. So yeah, so some of the devices I unplugged just so that the battery doesn't wear out, because the batteries are last about an hour or something, approximately, so trying to save battery on that. But yeah, the other thing about the ESP8266 is that you can program it with the Arduino IDE, which is a big boon, because there's lots of software that people write for the Arduino, very popular. And yeah, so, okay, so all of these devices you have here are connected to a router I have up here, and they're connected via MQTT, and they're sending the value of their joysticks, and they're also listening on a value, or on a channel for the LEDs on each of them. So you'll see there's also, an LED separate from the red LED. The red LED is like Wi-Fi, and the separate one will be individually controllable. So this will be an example of, you have devices out there, they're producing data, they're also listening on stuff. So I'll show how that works.
They're all on the same channel?
So actually each device is publishing its joystick values on 2 channels. One individual to the specific client, like all these clients have UUIDs and they're publishing their own value on their own channel. And then there's also a global channel that all of them are publishing on. So in a second, I'll listen to individual ones. I'll listen to the ones specifically on up here that I have. And then I can listen to a specific one out there, but then I can also listen to all of them because they're sending on a global channel. So yeah, that's that. All these, I neglected to include like a parts list for this, but all of this was like, I think, under $15, I think, for all the parts here, buying in bulk, etc. So yeah, so these ESP8266 chips are pretty cheap and accessible here. Okay, yeah, so let me load this up. Yeah, so the joystick is being put on both the joystick channel as well as each client has a UUID. I'm going to go back to full screen here. Here we go. Okay, so the functions I'm showing you will be the exact same as the channel framework functions, just to avoid, because it's like an experimental version, they're all prefixed with MQTT, just so that I avoid clobbering the same names. So here we can look at, here I'll get rid of the short. So we can use find channels to find all of the channels that are currently being processed here. And so you can see all of these joystick channels. I don't know which, that's one of these devices out here has that UUID, et cetera. So there's all these channels. We can listen on one of them. The UUID of the one I have up here, the UUID is just master, just so I know which one it is. So we can listen on that. If it wants to cooperate. Yeah, so I'm going to quit the kernel. Hang on. Sorry, it seems to be stuck. That's probably why. Okay, one more time. After restarting the server. Okay, there we go. So now we're listening on master/joystick, which is the one that's being published here. We can do a dynamic of that. So now, if I switch back so you can see this. So that's the values being updated dynamically. So if I move joystick over, it's just being published 1 a second. So it's a little slow to update, but you can see it move around as I move the joystick around. Works all well and good. And then this looks a little ugly because it's all side like that. But we can easily make a plot of this. So with the listener, you can get a data set of the data. So there's all the data, and there's some metadata as well included with this. We have the message, which is the actual data, a timestamp, what topic it's on, and then there's a few things, a few metadata things here. So we can make a dynamic plot of this. So you see it moves, and then if I adjust the joystick here, you'll see it move around. So that's on this specific one, and I could go and listen on one of the ones out there. I have all the UUIDs here on each of the breadboards in front of you. Underneath where the cable is, there's a little letter written in Sharpie. on the front of the breadboard underneath the cable. First I'll show, so when I send a message on the master LED, you'll see the LED comes on like that, and then if I turn it off by sending a 0, it'll turn off. So these are the UIDs, and Jason, what letter is yours on? X. All right, there we go. Let's turn X on. The LED come on? It looks like, yep, so we can turn it off, etc. And then if I want to turn all of them on, I just send message on all of those. Looks like a couple got disconnected there, but for the most part, all worked, and then I can turn them all off from up here. So this is how you could do remote control, right? Each individual client is listening on a particular channel that you can use to control that particular one. And it's easy from the Wolfram language to control all of them at once or control individual ones. You could make buttons, you could make whatever kind of manipulates or graphical user interfaces you want. But yeah, so that's kind of how you do that. Now all of these are also publishing on the global channel, the joystick channel. So I can actually before I do this, I'm going to turn the other listener off just so. Just because like all of this, all the server stuff is running on my machine, and so the more I can let my machine off the hook, the better. Okay, so I'm going to quick listen on this global channel. And you can see it's growing pretty quickly because each of these are publishing at one a second. So now I'm going to try and do this dynamic. Hopefully it can handle it. So you can see them all move around. So now if everybody on the one in front of them like pushes the joystick to the left, we can see, try and see the aggregate of all of these go down. Some of them nobody's in front of, so nobody can do that. But yeah, so this is, you're producing data. It's showing up here, and yeah, we're live plotting it. So this is all live generated data. I'm going to shut this off for a second. And yeah, and we still have the specific values up here. So yeah, I'm going to stop listening on this for just a second. Okay, so let's talk about, so this is the Arduino sketch that all of these are running. Can I zoom in a little bit? Okay, so this is just simple sketch that the Arduinos are running. These are some constants. I don't remember which specific device this is out here. Set up some constants. And then the setup function, we just connect to SPI because we need to connect to SPI for the analog to digital chips. We connect to Wi-Fi first at the top and then turn the pins off just because that's there. The Wi-Fi, there's real easy Wi-Fi libraries available for this device. So you just do Wi-Fi.begin with the SSID and the password, and then wait until it gets connected. So the Arduino software can program this device. You can use the Arduino software. Originally, the Arduino software came out to program just the Arduino board. But because the Arduino software and the Arduino device got really, really popular, people started expanding the software so that it can upload to other stuff. So like, for example, on my machine, these are all the different boards that I can program because I've installed a bunch of different stuff. So there's like all these chip kit stuff, all sorts of like random boards. So you can use the same software, the same Arduino software to program a bunch of different devices. And that's what I've done for this. And I'm just kind of walking through the sketch that this is running. So this here is the callback function that's called. You can ignore these debugging print statements. But basically, we just check to see, if the message we got is that the client LED topic. If it is, then look at the payload, which is the message that was sent. And messages, currently, they're being sent as JSON. Not JSON, but JSON as in the format. And luckily for us, in the JSON format, 0 and 1 is just the character 0 and the character 1. So we can just switch and see what it is and turn it on or off. You can also send more arbitrary, like complicated expressions, just that in this case, 0, 1 seem to fit. But when you send data so when I do like, I think you might have noticed this before, but when I did, if I send, nope, not listen, send, say, to hello channel, I can type whatever arbitrary expression I want. So like if I just do something like that, oh, I guess that channel doesn't exist. Here, I'll just send it to master joystick. I guess nobody's listening. But you can send whatever arbitrary expression you want. So if I wanted to send like, I don't know, an image or something, like current image, oh, that's kind of dark. I take this, or Mathematica could crash. But I was probably asking you too much to do all this and take a picture. One or the other probably. But what I was getting at is that we encode expressions when we send them, so you can send whatever arbitrary expression you want. And this is, question? Yeah.
So in your Arduino code, there must be a URL of which you must be listening. Is that hard-coded on the computer?
So in this case, I specifically, a better way to do it than how I did it, because how I did it is I just ran a little script that generated 30 different sketches, each of which the only lines changed were this UUID. And so the UUID is hard-coded, and you can see these are like the URLs kind of that they're publishing on and listening on. That was not the smartest thing for me to do because originally my sketch had a typo in it, and so they were all sending on the wrong, or they couldn't connect to the Wi-Fi network, and so I then had to re-upload the sketch to all 30 of them again. So a better way to do it, I think, would be to have each of these like connect to a server and like get their UUID dynamically so that they can all have the same sketch, and I don't have to re-upload it 30 times when I make a mistake. But yeah, you can generate a UUID from the MAC address. Some of these devices, though, are kind of weird with their MAC address handling. Like sometimes they show up as the same MAC address. Yeah, I mean, yeah, there's lots of different ways you could generate a UUID programmatically. This was just the simplest way that I saw, so that's what I went with. But getting back, so yeah, that's what, when we get a message, that's what we do. We see if it's 0, if it's 1, and write to it. And you can see, so we just have that one subscribe function, and then to ensure that that gets called every time that we get a message, all we have to do is connect or subscribe. We'll connect to the server, obviously, and then call this function subscribe, which is like a standard function that you'd call with any MQTT client library. And then in this case, we just call client.loop, right? We don't have to worry about long polling. We don't have to worry about like checking to see when messages are done. The library takes care of it all for us, and it's a very nice, easy way to connect to the device. And actually, you see like how we're sending the data is I just hard-coded in the JSON and print in the values when we read from the ADC. And then I have a delay in there. These devices are actually pretty fast. When I had one device publishing without any delay, it was sending like 200 messages a second, which times 30, my laptop can't handle that. So yeah, I just have a little delay in there. And then this ADC read function is just some simple SPI code to read from the ADC. But okay, go back to.
You mentioned earlier turn off, or maybe you didn't mention, I saw on the screen, turn off command. Would that be able to be sent here, turn itself off?
Yeah, I can. So yeah.
Then turn back up.
Yeah.
Also?
Yeah, so what that command, how I have it set up is just for the LED, but you could certainly have that for other devices, right? A lot of times sensors that you'll attach to have like a low power mode, and you could certainly send a message to devices and tell them like, oh, go all into low power mode, et cetera. Let me get back in here.
Did the server run on a Raspberry Pi?
Yep, Yep, lots of people do that. Lots of people have, especially for smart or like smart connected homes, is they'll have like one Raspberry Pi that's running an MQTT server and connected to the network, and then they'll have a bunch of cheaper devices like what you have in front of you that are like $5, $6 connected around the house that connect via Wi-Fi. So that's pretty common. I've seen that done a lot because you have the Raspberry Pi running your more complicated software. It's still not like a full weight server, but for smart home stuff, it's usually enough. And then you have smaller, cheaper, more power efficient devices out attached to your sensors that way. Yeah, so that's what I was just talking about, showing all this. And then that's when I listened to all that. Yeah, okay, so there are other devices that we can connect, one of which is the Arduino Yun that I have. With the Yun specifically, with 11.1 or 11.0, so on the shipping version of 11 you have, you can attach an Arduino Yun and deploy a function that uses the Yun's Wi-Fi capabilities to connect directly to the channel framework. So you just plug it in and do like device open of the Arduino Yun, and then device configure of like, I don't remember the exact syntax. Well, actually, there's a guide in the documentation center on how to do this. Well, specifically with the Arduino, with data drop, but. Oh yeah. Oh, that's where it is, right? Yeah. And the applications, devices. Here we go. Yeah. Yeah. So all you have to do, you just open up a connection to the device using device open, and then you can upload this little function, which. So this specifically, what we're doing here is uploading what's called a boot function to the Arduino, so that as soon as the Arduino turns on, it runs your little function. And here we have special functions coded for channel send. So this sends to whatever channel you specify the value of pins A0, A1, and A2, right? So that's a pretty easy way to deploy stuff out in the field today using the Arduino Yun to send data, but again, listening is a more complicated matter because of how the HTTP server currently works, which is why we're going to expand it to MQTT. But yeah, so there are other devices like the Arduino Yun. Raspberry Pi is another example of a device that you could connect and use this for. Yeah, there are lots of other like smaller devices. The advantage, like in Internet of Things, a lot of times you'll see people have lots of different kinds of devices, and so they're going to connect to the server in perhaps different ways. But the point is that when you use a channel framework and use mathematical Wolfram language with this, you get a unified way to access that data and control those devices, which greatly simplifies applications. So this that concludes like the set part of my talk, but this is a workshop, so I'm going to open it up to any questions, or if you want to see demos of anything else done with all the devices in the room, free to do that for you. Yeah.
So you're going to host a MQTT server at Wolfram?
Yep. As part of the channel framework, yes.
Are you going to abstract this so I can host my own MQTT?
So what we're going to do is when we have the ability in the channel framework to use MQTT as a method, is we're going to be able to connect it to your own MQTT network. So if you have one set up behind your company firewall, or you're on your own home network or something that's not live to the internet, you will be able to connect it to that MQTT server and use the same set of functions just on that local version. Is how we're anticipating that. Again, not sure if that will be like 11.1 or 11.2, but that's functionality that we would very much like to bring, and that will be coming. So.
Are you going to enumerate the hierarchy of MQTT?
There's some, yeah. So in the MQTT protocol, there's some features that we're not taking advantage of with the channel framework. As to whether or not we'll expose those, underlying the channel framework is a package that literally just does the MQTT protocol. And so you'll be able to like create your own clients and do your own straight MQTT stuff, but that's like internal stuff. So with the channel framework like layer of all those functions, some of the MQTT protocol will be exposed, but some stuff like retained messages and other aspects of the protocol might not be there. So.
What's popular use for this Arduino Uno?
So a common thing that people use it for is because it's so the thing about the Arduino Uno that's special is it has a normal Arduino chip, and then this big silver chip is a MIPS processor that's running, I think, OpenWRT. I don't remember the exact operating system, but it's running like router software. So it can both connect to Wi-Fi, but it can also act as a Wi-Fi host, and it can host its own Wi-Fi network. So sometimes people use that and have this running little, so some people run MQTT servers on Arduino Uno, and then they have other devices connect to that. But yeah, the dual processor nature of this makes it very helpful for projects where you need that.
I noticed it has the Ethernet port.
Yep, it has
Wi-Fi
Ethernet.
also.
Yeah, it has both Wi-Fi and the Ethernet port, yeah. And the Arduino Uno is supported through Mathematica, so you can plug it into Mathematica and deploy, your functions that send to the channel or to data drop as well. We have support for that. Another question?
Timestamp, that was a local within your Mathematica kernel.
So the timestamp is when the message is received on the machine, because there is a timestamp that happens on the server, but just for the purpose of this, I was just using the timestamp of when it's received, because there's no real good way of knowing when it was sent by the client, right? Because it might go through routers and you never. But yeah, so in this particular instance, it was being timestamped on the client when Mathematica received it. But for the production channel framework version, it's timestamped on the server. Just on this local version that I was running, is timestamped on the machine. But does that answer your question? Yeah. Cool. Yeah.
In the Raspberry Pi had a full load of Wolfram language on it, and then it would like update, when there was a new version.
Sure.
It would sort of automatically connect and update. Does the Uno do that also? Or?
So the Uno, updating the Uno is something that happens a lot less frequently because it's running like basically router firmware, like an open version of router firmware. And sometimes you do want to update it, and actually when you log into the Uno, there's a nice thing that you click check for updates, update available, click download, and then it shows like one of those bars like do not restart it during this, or else you'll brick the device or something. But I don't. The firmware the firmware on the router or the Uno rather isn't meant to be. The firmware on the MIPS processor on the Uno isn't meant to be updated very frequently. That's like supposed to not change very much. Yeah, exactly. Yeah, because you could brick the device when you do that. And then you have a very nice paperweight. Question? As long as it's reachable from the network. So in this case, all of these are sending, all of the data that's being sent here actually is never touching the internet. It just goes to this router, and then my machine is on the router running the server, so it just goes here. So it just has to be accessible through the network. So these devices could be set up to go all the way out to our public channel framework servers and then come back to my machine. It's just a matter of how your network is set up. In this case, they're not going out to the internet. That was also by design because the internet connection here is like pretty unreliable. And so here, it all goes straight to my device.
So these are securable?
Yeah, exactly, securable. And that's something that I know a lot of companies and a lot of businesses want to be able to do is have control of, and that's why we want to have the ability for a local MQTT broker, or not necessarily local, but like on your own internal network. You can be running your own MQTT broker and have plugins or whatever you want set up, and still use Channel Framework for all that data, but it just never touches our cloud, or anybody's cloud because it stays on your own thing. But again, that's future functionality that is not in 11.0 yet. So, any more questions? Yeah.
I have trouble following your point, but is this piece of hardware, what was it again? Is it listed in the notebook?
Yep. So, sorry, I'll go back to the previous page. The processor on here is called ESP8266. This specific one is made by like some Chinese company, like HI Let Go. I forget. I can pull up the Amazon.
But this must be a different notebook than is on the Passable site?
There shouldn't be a notebook on the Passable site for this talk. 'Cause the MQTT features and stuff here is still like pre-release stuff, and so we're not releasing. 'Cause the notebook I have has a bunch of code that is all running this that we're not going to release. If people want, I can remove all of that and just include like the bare notebook with just these diagrams and stuff.
The one on the Passable website is just 6 page slides. This is how many? 70? I can't remember.
11.
Yeah, but
I'm not.
this would be cool if it had like device or something.
Sure. I can upload a notebook that has the code removed if you'd like, but I'm not sure what notebook you have.
Well, whatever's on the site, unless I goofed and downloaded the wrong one.
It might be a different talk because I specifically told them I wasn't uploading a notebook.
Okay.
So there shouldn't be a notebook there. If there is,
It must be from your other talk.
it could be. It could be from the other one, the Vernier talk. Yeah.
Okay.
Sure. I'll remove the code from the notebook and upload it so that y'all can see the rest of the stuff. Yep. There's actually a newer version of the chip. This chip has just Wi-Fi, but the company Espressif that makes these just released a newer version that's like same price point, but also has Bluetooth. So if you're interested in that, you can get a better version than the one I have here. So.
Can we play again?
Sure. Yeah. Let me load it up. Where did the slide go? Okay.
Do you have like a game in mind?
I don't know.
Maybe try the one-liner phone from this morning.
What was the one-liner?
With like a searchable phone.
I don't know how you do that from. Was it? Well, like, how would you use the data here? I suppose we could do like a moving average of like where it is, and then try and get everybody to like move it somewhere. Yeah, let me. All right, so let's grab.
Leverage is going to be thrown off by the numbers that aren't doing anything.
Yeah, I know. Somebody could go around and unplug the ones that if they wanted. Let's do join. Do another join. So yeah, it looks like they're almost exactly in the center. Let's divide this by. Let's just make this. Oh no, disk. Values. I forget radius. Second. Well. So if we want to show the axes. I forget what the option is for graphics to show axis. It was showing up as red when I did that.
ES, not IS.
Oh, there we go. Okay, there we go. Let's make this a little bit smaller. Oh. Yeah. Yeah, this, I probably shouldn't have had that dynamic running at the same time. All right, let's try this again. Joystick. Let me delete that. Dynamic. Okay, so there's all the values again. Yeah, sure. So we do n mean values. Do you know how you set the range on a graphics? I assume there's an option for that. Does that work? Even though it's not a plot? Well, there you go. Let's do the
X
other
and
one.
Y.
Oh, yeah.
Maybe a range.
There we go. Okay. So I'm going to save the notebooks. We get this, and then let's wrap this all in dynamic and hope and pray that the front end continues to work. Okay. So, okay. So does everybody have the joystick? All right. Let's all move it to the right. Doesn't appear to be moving very much. It's moving very slowly. Here, what I'm going to take like the last 30 values, like rather than because it's going to continue to average with like all the time that it's spent not doing anything. So. Oh, poor front end. All right, one more try. I saved the notebook, so we have that code. One more try. Oh, yeah, you're saying, yeah, full screen makes it unhappy. I forgot. Okay, so if I take reverse and then let's try, yeah, let's just try 30. And then reverse again. I really wish up to of a negative number worked. That would save me so much time. I do that all the time. I suppose, but typing double brackets is just... Okay, all right, let's make this dynamic again. All right, so now if we all push it to the left. Oh, it's moving, look at that. Although I forget which... Yeah, I think left might actually be down. Yeah. Yeah, so I guess if you rotate it 90 degrees and then move it right, but yeah, this is like, what are those like games called? Or there was something on Twitch that was like this. Yeah, exactly, where they'd like average all of like a bunch of people on the internet choosing a thing. We made that in Mathematica. I feel pretty proud of ourselves. So yeah, any other questions or anything else you want to see demonstrated with this while we have all the devices here? Yeah, I think so. I'm excited for it.
So, I didn't quite get, is this ready to be something we can try at home, or it's not?
So the channel framework is all up and ready. You can use the channel framework. The only thing, the part of my talk that I was demonstrating is the MQTT aspect. So you can do this exact same demo at home. You just can't use MQTT. And so instead of like using the MQTT protocol on the device, so where I have all this Arduino code, where I like this, where I like connect and then subscribe. Instead of doing that, you would make HTTP requests. And so you'd like send values using, you do like a GET request.
So that would work with the same hardware, or would it not?
It'd work with the same hardware, yeah, exactly. Because the only difference between doing it via MQTT like I have and doing it via HTTP is with HTTP, like I mentioned, listening is a little bit more complicated due to long polling. But all you need to do in the code is, so like here in a browser, we could all do the same thing using our browsers. If we do using the URL of the channel that you're interested in, so in this case it'd be like /joystick or something, and then you do question mark mode equals send because it's a REST API, and then whatever ADC1 equals 500 or whatever number, you can do that from the browser. Because the data that was being sent via MQTT, you can send it via the browser too. So it's just going to a certain like web page and providing parameters.
Right, okay, so details are skipping a bit. And how does this little device become a REST API?
So that device communicates with the server right now through MQTT protocol. If you wanted to run this at home, you would take the device and instead of using the MQTT protocol, use HTTP.
So, and that's what, however it says on the homepage there to load that onto this thing.
Right, yeah. This sketch, which I'm going to put the sketch on the Pathable page. I didn't quite get a chance to do that. But the sketch, you would just change stuff. So right here, this line that says MQTT client.publish that value string. Instead, that would be something like, I don't know, like HTTP client dot, I don't know, get, and then you would include like the URL like this as a string. So you do something like that. Does that make sense? It's two different ways of communicating with the server.
I get that part. I probably wasn't paying close attention when you described how this device gets set up to show up on the internet at all.
Oh, so in the Arduino software I've pulled up right here, if I was going to change this to use HTTP, I'd just change a few lines of the code and then plug in the device. Like I have like plug it in via your computer over USB and then upload it through the Arduino software.
So it's that Arduino
IDE. Yep.
IDE, okay.
Yep, and you can go online. The Arduino IDE is like free. You can find it. If you search for Arduino IDE ESP8266, you can find the a tutorial that walks you through how to program it using the Arduino IDE. So yeah. All right. Well, I think that's 4:20, so got 10 minutes left if anybody has any other questions. All right, well, thanks for coming to the, oh, sorry.
Anyway, the MQTT stuff, that's like 11.2 or who knows?
11.1 or 11.2, yeah.
Okay, well 11.1 is pre-release now, so.
Probably 11.2, yeah. So, soonish. right, thanks.